So we would like to compute the value of this integral, and if we just do it by just like work it out, you can see this here, that first we have to integrate with respect to x, and we don't have anything here that we can use for substitution, right? So what we would like is that we would like to change the order of, or rather try changing the order of integration and see if it works before we go towards finding approximate values. So notice this, that in here first we were integrating with respect to x, and our x ranges from y squared to 9, right? And y ranges from 0 to 3. So if we look at a graph of this domain, so here what we have is that our y goes from 0 to y equals 3 here. Okay, so here y is 3 and x is how much? 9. So what we are looking at is that first we are varying x, or making variation along x-axis, informally speaking. All right, and look at the area of this element. Okay, so in here x ranges from y square, all right, or you can see this is the graph of y equals the square root of x to x equals 9, and y is going to vary from where to where? Y equals 0 to right here y equals 3. So changing the order will mean that we shall cover the region with elements like this. So in this case, now what happens is that we have that now we are going to integrate with respect to y first, and then what will happen is that y is going to vary from 0 to, one second, y is going to vary from 0 to how much? Y equals a square root of x. Okay, so if we are doing this, that changing the inner here to dy, then the limits for the inner will change from 0 to square root of x. All right, and for the outer values, you can see that now x, this element, is going to range from x equals 0 to x equals 9. So what we will do then is that our outer integral will be, or our outer limit would be from 0 to 9, and then we shall integrate with respect to x. All right, and now we may see this, that with y squared equals 2, we might be able to get something for substitution. So if you can't just see it like just thinking about it, let's go ahead and calculate. So what we are going to do now is that just change the order here, instead of first with respect to x and then with respect to y, to first with respect to y and then with respect to x. So x ranges from 0 to 9 and y ranges from 0 to square root of x. All right, so here we go, and then in here what we are going to do is that now we are going to integrate with respect to y, treating x as a constant. So you can see that the inner integral is going to be, let me just put that in parentheses, and outside we have dx. Okay, so that integral is going to be y squared over 2, all right, and e to the negative x squared, we treated that as a constant, and the upper limit is square root of x, and the lower is y, lower is 0 for y, right? So let's just bring it down in the next line. We can erase this now. Okay, so what do we get if we look at it? When we substitute y equals square root of x, what we shall get? We shall simply get square root of x square, that is x. All right, and then we get e to the negative x square dx. So let's pull 1/2 out. All right, and then what you have is right here, this simply changes to x. All right, so I shouldn't have pulled 1/2 out actually, but anyways, so now we can do this, that set negative x square to u. Okay, and then what that will do is negative 2x dx becomes du, or x dx will become negative 1/2 du, right? So the integral here is going to change to what? X dx is going to be negative 1/2 du, and here upstairs we have u simply, right? Okay, and 1/2, let me write 1/2, I don't know what is the rush. Okay, so this is 1/2, and then the limits will change from u equals 0 remains 0, and since u is negative x squared, the upper limit would be negative 81. So what we get is 1/4 and integral from 0 to negative 81 e to the u du, right? And that will be simply how much? 1/4. Okay, and then I'm just going back to the basics for calculus 1, e to the u. The integral is e to the u. Okay, and then the lower limit is 0, and the upper limit is how much? 80, negative 81 actually. All right, so what the answer would be then for that integral, we will have e to the negative 81. All right, and then I lost my negative sign here, didn't I? Right, so this is negative, then negative again, and let me bring these to the next line. All right, so then you have negative here, and then for the lower limit what we shall have? We shall have a 1. So what the answer will be? 1/4 times e1 minus e to the negative 81. All right, so let me know if this doesn't make sense. Okay.